Hello, everyone. Thanks for joining our session, Orchestrating Data Pipelines with ControlM. My name is Joe Goldberg, and I am joined by Basil Faruqui. We have two sessions in this event. This first one, Basil will take us through a discussion of the challenges associated with such orchestration and how you can solve or overcome those challenges with ControlM. This session will be followed by a Q&A. We have a second session where we will have an actual demonstration of our solution, and that will be tomorrow, which is Thursday, October the 14th at 2:15 p.m. Over to you, Basil.
Okay, thank you, Joe. So without further ado, let me get started and share my screen. Okay, I think everybody should be able to see my screen now. So as Joe said, today we're going to focus on the topic of orchestrating data pipelines with ControlM. But before we get into the orchestration, automation, and the challenges associated with it, it's important to kind of step back, zoom out, and take a very macro level view of what's really happening in the data world. So here's some stats from some market analysts talking about the enormous amounts of money that are being spent in the data analytics field. Uh, Not only there's a lot being spent, but the rate at which this spend is expected to grow is also very, very eye-popping. And I think events like this one, Big Data and AI Toronto, and many others that are hosted worldwide on a daily basis, I think are a testament to the interest, investment, and the real desire of extracting value out of data on a global scale. But when we look at kind of the outcome of all of this investment, there is reason for concern and pause because particularly the more modern, cutting edge, bleeding edge projects like AI, ML, deep neural networks, they're not really producing the type of results that companies would expect. And the stat here is pretty telling that 15% of these types of cases are expected to be successful. And another area that Gartner has, both of these stats are from Gartner, and Gartner has focused on one of the causes they have started to highlight has to do with operationalizing this because there's a lot of experimentation going on, but when these projects get to the operations stage, which is where they're supposed to produce the value they were intended to, uh, it seems like that is an area that is somewhat of a bottleneck to the success of these projects. But if we, again, at a macro level, look at why are these things failing, and there are multiple reasons for this. Now, certainly this is not an exhaustive list, but some of the ones that we have seen within our own customer base and the industry at large is, first of all, just the amount of data that is available to be stored, processed, analyzed. The sources and the amount of that data has really just exploded. It has gone from just being systems of record data, data that was within your own data center or cloud. It's just not limited to that. In fact, many estimates suggest that the amount of data that exists outside the organization that your organization is interested in is actually much larger in volume. This is data from sensors, devices, clickstream data, social media data, and so on and so forth. And all of this must be, securely brought in, processed, analyzed. And this first issue has created a lot of the subsequent issues, which is, for example, a process mismatch. A lot of the traditional approaches to data management, data warehousing don't lend themselves very well when you're looking at a very, very high speed, hyperscale data environment where you've got unstructured data, streaming data, batch data, and you really have to zoom out and think about, well, what process is right to get the desired outcomes. And of course, automation and orchestration are not trivial here. They're of paramount importance where you have to apply these to the max so that you can get to the end results not only faster, but in a much more reliable way. Uh, the previous slides we talked about that this stuff is not cheap. There's lots of amount of money that's being invested, and further complicated by the fact that there's a scarcity of talent globally in the space of data engineering, machine learning, data science. And now that you have so many different teams, data scientists, data engineers, operations people, business folks, there is a need for collaboration. And quite frankly, again, a lot of the traditional approaches did not lend themselves to the high degree of collaboration that is needed to produce the intended results. And all of the investment that is going in is on the vendor side, is even in the open source community. There's just a lot of technology coming out on a daily basis, and there's always a temptation to go after the latest technology in the hopes that this will solve the problem faster, better, cheaper. And of course, there's quite a bit of confusion on, well, how do you measure the value, the success, even sometimes measure speed at which things are getting done here. So, like I said, these are some of the main reasons that we see out in the industry, but today we're going to focus on two areas: automation and orchestration and lack of collaboration. Okay, so again, let's take a high level macro view of what is the challenge with automating and orchestrating data pipelines. When you look at a data project, whether you are talking about a simple BI project that's doing some dashboarding and reporting, or you look at a cutting edge ML and AI project, you can break that down to these four key stages: ingestion, storage, processing, and insights. And there's immense complexity in each of these. Ingestion, we talked about earlier, the data sources and the amount of data that you have to ingest is growing and arguably growing exponentially. The storage and processing, where do you store all of this data? How do you process this? Cloud has become often a platform of choice to do high speed, high scale data processing, for obvious reasons such as elastic compute, the ability to pay for only the resources that you need, be able to spin that down when you're not using it. And the same story on insights, the way you analyze data. It's not just limited to dashboards and reports and charts, but there are machine learning algorithms where you feed a lot of this refined process data so that it can do pattern recognition, recommendations engine, and all those kinds of things. And when you think about delivery of this on a daily basis in production at scale, obviously everybody will agree that this should be a highly automated and a highly orchestrated process with minimum human interaction. And whenever there are problems anywhere in this pipeline, so to speak, the right people should get notified, and you should be able to understand what happened, 5 steps above in the pipeline, what should happen, what is expected to happen down below, what's the impact of a failure, so on and so forth. All the things that are so crucial to running these things in production at scale. All of that sounds good. However, let's get to what's the challenge in automating and orchestrating this. So on the far right, let me go ahead and just build this out. On the far right here are sort of the business outcomes that are desirable from the investment in data projects. Things like predictive maintenance, if you're in manufacturing, oil and gas, or any kind of large-scale logistics and transportation industry. Predictive maintenance is a very, very hot use case. Fraud detection is very, very important. Customer 360, and so on and so forth, right? And in the middle is the complex stack of technology that's being used to build the data pipelines, ingest the data, and deliver the results. And on the left-hand side of the screen are a growing number of teams that need to work with this technology stack to deliver these outcomes. And as I mentioned earlier, everybody says, well, this should be a highly automated process. And the challenge is that with so many different technologies, and often many of these technologies come with their built-in automation packages, when you think about automating a process, a pipeline from start to finish, you cannot afford a different approach at each stage with a different piece of technology. And that's really the mission for ControlM, is to provide a layer of abstraction over all of this technology so that you can orchestrate data pipelines from start to finish. When there's a problem in a data pipeline, you should know exactly where the problem is, get the right people to be notified, automate even some of the remediation, such as, if a data transfer has failed because there was a network glitch, well, maybe the right thing to do is automatically restart the process 3 times, and if it still fails, then notify somebody, right? These are all characteristics that are desirable or required at the production stage of data pipelines and data projects. And ControlM provides not only a way of connecting disparate pieces of technology and orchestrate a data pipeline, but also do a lot of the detection, impact analysis of a problem, notification, so on and so forth. And as Joe mentioned earlier, there will be a demo tomorrow where you'll get to see some of these things in action. ControlM today is available in 2 consumption models. One is the traditional on-premises. The other one is Helix ControlM, which is a SaaS offer. What we've really found in the market is that the customers are in different stages of their strategy and adoption. In some cases, a SaaS solution is preferred. In some cases, on-premises is preferred. Many times, on-premises is a requirement because of regulations or geography or local laws. So with ControlM, you have both options available. The second challenge is around collaboration. We talked about, well, the number of teams are growing. You've got data scientists, you've got data engineers, you've got SREs, you've got operations folks. And this need for speed and you cannot achieve speed without good collaboration has given rise to other disciplines like data ops and DevOps. And when you think about orchestration of data pipelines, it is really, really important that collaboration is as close to frictionless as possible. Now, traditionally, the collaboration to get these workflows automated into production has been somewhat like this. Developers who are building these data pipelines and writing the ML algorithms, they will communicate to their IT ops and schedulers, as those teams are often referred to, as here are our requirements for automation, and you need to go implement these in production. And the operations teams are responsible for the production environment. They have production standards. They're responsible for running these things at scale 24/7 with disaster recovery, 0 interruptions. So they have a lot of standards that they have asked developers to comply with. And this whole compliance and collaboration has really, quite frankly, occurred through service desk tickets and emails and a lot of informal collaboration. And when you think about delivering things fast and at speed, and you look at a process like this, you're like, well, that's pretty chaotic and really inefficient and doesn't lend itself well to agility and speed. This is where ControlM introduced several years ago a concept called jobs as code, or you can just refer to it as an as code approach for orchestration, and shift left, meaning allow orchestration to be built into the software development lifecycle versus treating this somewhat of a fire drill activity right before going into production. So what do we mean by as code? Well, a developer should be able to define a workflow very rapidly, whether they use a graphical interface to drag and drop and then convert that to as code, or simply design it in code format. We support JSON today as the language to define ControlM workflows. And instead of opening a ticket to let their counterparts and ops or the SRE side know that, hey, here's a workflow that you need to now deploy into production, they should be able to use the same CI/CD pipelines to deploy ControlM workflows that they use for deploying the rest of their application and code. So, develop in your workflows, commit them to a source code repository like Git, use a tool like Jenkins to automate the delivery and testing of ControlM workflows. So you commit it, you go to the next stage where you want to do some automated testing. And the automation API, which is essentially a set of REST APIs exposing ControlM capability, allows this approach to be much more efficient because now you're putting things through an automated pipeline versus opening service desk tickets that require a human on the other end to analyze the request. Now, this automated pipeline doesn't mean that this is happening without production standards. And quite frankly, operations folks can now focus on governance and standards versus taking requests and implementing them. For naming conventions are really good examples. So if I've defined a workflow with 50 jobs, I cannot just call them all job 1, 2, 3 because that was convenient. In production, those names must have certain standards and codes that they must follow. An automated pipeline in the testing phase will ensure that the production standards have been implemented, and if not, it can stop it in the pipeline at a stage where it can be rectified versus taking it all the way to production and then having somebody raise the red flag and say, well, you've been working on this thing for the last 3 months, but this really wasn't built to standard, and you need to go back to square one. The other element of this is business users. There are process owners in the company that are interested when you're running these things in production on a daily basis. Are they on time? Are they late? If they're late, by how long? This is much like our need and for tracking a package that has been shipped to us. Is it on time? We don't really care who's the driver, what kind of truck it's on, but is it on time? If it's not on time and it's delayed, by how long, so that we can make plans accordingly. And ControlM offers mobile apps as well as web interfaces where process owners and business users can track the status of their workflows, much like we track a package. So let's take a look at a real-world example. Malwarebytes has been a ControlM customer for several years, and their primary use case for adopting ControlM was automation of their data pipelines and ML pipelines. Now, Malwarebytes has an interesting business model. They offer a paid version of their software as well as a free download. And between the two, there's been over 500 million downloads. And at any given point in time, hundreds of millions of endpoints are running Malwarebytes scans, and that data is being streamed back to Malwarebytes. Now, they have lots of uses for this data, but their primary interest in this data is being able to identify the top 1% most harmful malware viruses that are emerging on a daily basis. And the volume of this data is quite staggering. They're ingesting, over 1 trillion data records every day, which must go through a complex data pipeline of storage and processing, feeding it to machine learning algorithms so that their research teams are always on top of the most harmful threats that are emerging. And they need to be able to do this, in very tight deadlines. This is not an activity that, okay, well, we've started data pipeline. If it finishes in 1 hour, it's fine. If it takes 4 hours, it's also fine. These are, quite time is of the essence, so to speak here, right? Now, I don't have time to go into a lot of detail here, but Malwarebytes has done a very, very detailed blog which talks about their architecture, the business problem, how they attacked it, and I've put a link to the blog here. But here is a very, very quick view of their architecture. This is also available in the blog, where the endpoint scan data is coming in, and through Kafka, it's being streamed into a Lambda architecture here, where the top layer goes and takes some of the data. Kafka does some of the processing here, and it reports it to kind of a leaderboard-like dashboard. And then the second layer, which is more of a micro batch and mini batch layer, where data arrives into S3. And from there, it has to be, moved from S3 to Athena so that some of the SQL that needs to be run on top of it can be done. It can be, visualized into Tableau and Looker, like visualization tools. Some of the data needs to be fed to ML algorithms. They're using SageMaker for that. And the BMC icon here represents several stages where ControlM is orchestrating this activity and making sure that, the right data goes to the right layer. It happens on time. When there are problems, the right people are notified. They know that, oh, is this a problem with the ML pipeline, or is this a problem with the pipeline that feeds Tableau, so on and so forth. So I would encourage you to go read the blog and really understand how they've leveraged automation to run a very, very complex ML AI pipeline at scale with trillions of data records. So as Joe mentioned earlier, tomorrow, October 14 at 2:15, Joe will take us through a demo and you'll get to see a lot of what I've shared here in action. So highly encourage you to look out for Joe's session tomorrow. And I think this would be a good time to get to Q&A. So Joe, I've been talking a lot. I'm going to take a break here and grab a drink while you check if we've got questions from the audience.